Project 3 serves as the connecting point between the work done in Projects 1 and 2. The robot's operating environment was constructed, and the code developed in Python and Arduino was integrated. Finally, the system's operation was tested. For the robot's operating environment, I used a trifold cardboard presentation board rested on a block of wood to pin the robot through nails and duct tape. This prevents the robot from making extraneous movement, allowing the end effector's position to be accurately controlled. The object used for the pick-and-place operation needed to be light enough to manipulate, dense enough to prevent wobbling or unexpected movements, and polygonal for operational stability. With these factors in mind, I chose to use a rubber eraser. Finally, I used the kinematics code developed in Project 2 to choose pick-and-place positions. The Python-Arduino connection was done through serial communication. The Arduino end of this was simple. I used the built-in serial library to connect to the serial channel using USB. The Python side was implemented using the PySerial module. Next was testing. The operation begins by having the Python program initialize the serial channel. It then waits for the Arduino to both connect and send its notification signal, triggering the Python color detection function. At this point, the 4 positions can be associated with the 4 colors, starting from position 1. By convention, the position associated with green is always chosen as the rubber eraser's first position. From here, the user can begin to input colors for pick-and-place operations. If the same color is presented consecutively, the robot will ignore the input and wait for another one. As we can see, the robot performs as desired, meaning this project can be considered a success. I'm grateful for having had the opportunity to complete this project, and I've learned a lot in the process. Thank you for a great semester.